Alrighty, class.
Yes.
Thank you for everyone being here and wonderful students. Everyone's a wonderful student, I will say that. So, our objective is Intro to Histograms. Intro to Histograms. So we have, it's a bar graph of the distribution or pattern of outcomes. So it means how many times did that happen? Okay, so it's not the value, it's how many times that item happened. The data is divided into intervals for a histogram, which is commonly referred to as the width. Yes? Yes? Okay, good. All right, and it says all intervals have the same width and piece of data falls into one interval. So, for an example, right here for this one that we have, it says the interval is, for the one that's pointing out, from 0 to 4.99. So in this first one right here, any data, so if I get another score or whatever this is coming from, oh, it says percent Hispanic. Okay, all right. And I guess it goes by class. I couldn't read it earlier, and it was kind of blurry, so I was like, yeah, whatever that was. And so, yeah, Hispanic?
Yeah.
Or does that say his panic? That's quite possible, too. See what I did there? Hispanic or his panic, hyphenated. Yeah, comma's a good thing. All right, so how many times it happened? So, by percents, that means in one of the classes, if there was another one, it would go up more, right? So one more person that is Hispanic, then this would go up one more unit. Does that make sense or no?
Yeah.
Sense or nonsense? Okay, good. So followed by 5.99 and so on. So this is 5 to 9.99. And so anything in this category between 5 and 10 would get added over here. If I had, okay, so how about this one right here? So between 20 and 25, what percentage is Hispanic? 0. There we go. 0% right there. Okay, so up there, percent Hispanic, we have 0 of them. Does that make sense or no? Sense or nonsense? Okay, come on, seriously. Everyone had lunch. Okay, you can't say that you're still asleep because, you know, you don't get the itis because the food ain't that good. And you've been awake long enough to actually not fall asleep during my class, right? It's not first hour. You can at least try a little more. Please, please. At least pretend to be excited. Right, Lashka? Thank you. All right, so now this thing right here, okay, describing a distribution. And you know what? I'm going to put right here. Describing a distribution. So for describing a distribution, we have some data that I'm going to throw up there. And this is going to be, the first one is shape. The next one is going to be, dang it, I totally forgot. I was like, man, I got this. But then guess what? I lost it. Gotta pull up my notes. Come on, internet work. Because it's making it even worse. Now the internet's got to be slow because I am recording this and you could hear me floundering here because I totally forgot what this one was supposed to be because... Oh, I already had it up. Dang it. Okay, there it is. Okay, yeah, shape. And then it goes unusual items. The next one is center. And my last one is spread. So for here, we're going to go through and describe the shape of the distribution that we have right there. So going up, back up to this one. Okay. Now, we're going to talk about, is it uniform, symmetric? Now, a couple things. Symmetric means that it's the same as the left side and right side. So it's like having, remember geometry when we did a reflection? Okay, that's what symmetry means. Or symmetric, so it matches left and right. So there's another one that we could say, is it a bell? So a bell shape would be, you know, here's a bell shape right here. So if I'm looking at this, it would look like this. And then last one is skew. And I will talk about skew here in a little bit. Jess? Okay. Next one is unusual items. So unusual items is going to be, here, I'm going to actually pull up my notes on this because there is a graph to go with unusual. So I'm going to show you. So irregular, so this is unusual items. They may appear clustered together or may not show just one peak. So if you notice, we don't have just one large value here. We have two large values right there, then everything else is between. Does that make sense or nonsense? So that's irregular, where the problem that we had earlier was regular. It was normal, it wasn't irregular. So that one also had another thing, and you are going to draw. You know what, I might as well give you the drawings on this. So here's the bell curve one. That's the one that you already did. And skew. Skew is interesting because it's kind of backwards. So where is all the data piled up at? On the right, isn't it? It's all over here on the right. But this one's actually referred to as skew left. So if the numbers pile up over here on the right, that means it's skewed left. So it's always opposite. And I found out earlier because I actually taught the class the whole time thinking it was the other way, and someone actually came in, they're like, hey, I think that one might be off. So, all right, so that one is skew left because it's backwards. So I know you guys are all drawing this, right? Because it's super important. You're gonna need a reference when you're talking about skew left. And I know a lot of people right now are just looking at this and say skew that, but you need to draw it anyway. See what I did there? I made a joke, and then I told you to do your work. So at the same time. I know, right? Man, seriously. Man, my jokes are great. I should be getting like applause and stuff here. You know, yeah, see, yeah, I know. I need to get like one of those buttons that like the crowd is laughing and just do like a laugh track all the time. Or I could do like one of those like gongs or like a wah, wah, wah. That's always good. Okay, so there is skewed left. And the next one is going to be skewed right. If you notice over here, they're piled up on the left-hand side, aren't they? They're piled up, so it's a high over here, okay? Not just right here, okay? But it's higher over here. Okay, and so this one is going to be skewed to the right. All right, are we almost done copying it down? Anyone still need it? Hey, Joe there, you still need it? All right, so let's take a look at this. So we talked about these, okay, talked about distribution of a shape. Here is this one is uniform. Okay, if you notice, whenever it's uniform, you can look at it like this because it's also going to be symmetric. Draw a line down the middle. That's the easiest key to help me do this. So I could tell if it's piled up on the right-hand side to be skewed left, if it's piled up on the left-hand side, if it's skewed right, or it is symmetrical, like this one is here, and it is uniform because they're all the same size. That's uniform, all the same size. Does that make sense? Okay, so I'm going to move on from here. Okay, here's the bell-shaped one. I just like mine on my notes because it was bigger. So we got this one. This one right here, again, this one is skewed to the left, skewed to the right. There's my irregular. Unusual items. Unusual items. So is there a value outside the pattern? A potential outlier. So we'll look at this. Okay, is there anything that could be an error? Are there gaps in the data? So now for this right here, that's what we're looking for. And these are my irregulars. Okay, these are my irregulars. IRRUGULARS slash, oh, my slash went the wrong way. Unusual items. There we go. So something that looks completely weird. And I gave a big speech to my other class about, difference between mean and median. And it took like 30 minutes to do it. But, I'll give you like the short version of it because you're still copying this down. So, if you're living in the neighborhood with Jeff Bezos, you know who that is? Yeah, like richest guy in the world, I think right now, $200 billion. He owns Amazon. Okay, that guy. If he lives in your neighborhood, do you think, if he lives in your neighborhood, everyone's going to think because he lives in your neighborhood that you live in the rich neighborhood, right? Yeah, but guess what? He's got all the money. You're living in the trash can next door. Okay? So, the outlier would be Jeff Bezos living in your neighborhood. That's why everyone thinks it's the rich neighborhood because he is an outlier. Not everyone is billionaires. But even though that you're living next door in a I said trash can, but it could be like a 3-bedroom house, like a normal person house, right? Could be a normal person house, but everyone's going to think that you're rich because you live next door to them. So that would be an outlier of the data of your neighborhood. Does that make better sense? Yeah. Okay, last year like that one. Okay. All right, can I move on? Yes, going to anyway. All right, describing distribution center. So, let's look at this, knowing the relationship between mean and median. So, right here, there's a median, and median, what does median mean? From yesterday, what does it mean? The middle number, right? Median means middle. So, right there in the middle, and mean is not just your math teacher. What does mean mean? Starts at A, ends in Vig. Average, thank you. Mean is the average. So in this one right here, that the mean is less than the median, this is going to be skewed to the left. This one right here, draw that line. That one is what? Symmetrical. Very good. Draw my line right there in the middle, which is my median. This one right here, I would say that my mean is more than the median. This is going to be skewed to the right. Use median if data is skewed or has outliers. Okay, use mean if data is symmetric. So this tells you which one you should use. Okay, now, again, this goes back to Jeff Bezos living in your neighborhood. Because everyone thinks that's a rich neighborhood because, you know, people in that neighborhood make a lot of money. Even though it's just one person that makes 200 billion. So we take, let's say everyone in here lives in the same neighborhood. Jeff Bezos moves in. What do you think the average income would be in that neighborhood if Jeff Bezos moves in? Probably about a couple billion dollars, right? Because average means we take it all together, we add it all up, and divide by the number that we have. In this case, it would be 30. We would take his 200 billion and the sum of all your guys' income, $25, okay, is going to be divided up equally, and then everyone would be billion. Everyone would have an average of billion. That's what I mean about an outlier. Okay, that's an outlier here. So that means that not everyone in that neighborhood makes $1 billion. But because Jeff moved in, it's going to raise up the average. But instead, the median would be middle number. So what I'm going to do is I'm going to put some incomes on here. And let's say that we have 1,000, okay, because 5,000, 7,000, and my 2 billion, 200 billion. So I'm only putting 5 on here, so we're not playing with our cell phone while we're trying to be writing notes right now. So let's take a look. A median would be middle number, right? Say yes. Middle number. So to calculate the median, all I do is they are in numerical order. I cross them out from one on the left and one on the right. So cross out that one, cross out that one, cross out that one, cross out that one. So the median income of our neighborhood is 5,000. Even though that Jeff Bezos lives there, he makes a crap load of money. That's closer to what our income would be, right? That's why if there's an outlier, you use median. And if there's no outlier, this guy to mess up my data, then I would use median, which is average. So they're both important, they're just used at different times. All right, I know no one in here is falling asleep because their pencil is down and they're copying this down, right? Not implying that anyone in here would fall asleep. All right, so describing the spread. Here's the one that we did earlier. Here's the one that we did earlier. So we're going to be describing the spread. Now, what was S? What was the S? Shape. Okay. So now where's this? So this shape right here is, what's it look like?
Looks like it's skewed to the right.
Yes, it is. It is skewed to the right because it's piled up over here on this left, right? Left, right, right, right. It is right, right. So it is skew to the right. Ah! Come on. All right, skew right. U. What did U stand for? Anything unusual here? Not really. Not really. Okay, so I'm going to say none on this one. C.
Center.
Center. Let's draw the center. There's a center. Looks like it right there, right? Right there in the center of that. And then S would be what? Spread. There we go. Now, how far is it spread apart? It goes from 0 to 45, right? But each width is how much? 5. Very good. It's only 5. So there's 5 in between. So it is 5 units wide there. Okay, and the spread, so my minimum would be 0, my maximum would be 45. Depending on if it's talking about the spread from the whole thing or one bar. Jess? And this is the last one for today. So, let's take a look at it. So, S. What is this S? Is it symmetrical? And
Yeah.
it looks like it, so I will do this right here. Look like 3 on that side, 3 on that side. Hey, I would say yes. There we go, symmetrical. U. Is there anything unusual?
No.
No, there's nothing unusual here, right? C. What did C stand for again?
Center.
Center. All right, look, we got the center right there down the middle, so it's going to be nice and pretty, symmetrical. And what was that last S?
Spread.
Spread. Okay, so it doesn't actually have units on here, but it doesn't start at 0. Okay, it starts here, right? And here to here. So I like having units so we can see what it is. And one of the things that you're going to have on today's homework, which you will do, Ariel, okay, is it's going to ask for the width. When it's asking for the width and it talks about class width, it's referring to one bar. One bar. What's the width of one bar? Okay, on the homework it actually specifically says class width. Now, guess what? Like I said, that's my last one, so I'm done with the notes for today. What I'm going to do is I'm going to show you the homework. So, you guys all have the homework in front of you right now because I did print it off for you. It's going to go on what page in your notebook? 30. And you will tape that bad boy in there somewhere once you're all done. So, if you look right here, you have to read the little story or information given to you at the beginning to help with this. What is the most frequent outcome? Jahir, what is the most frequent outcome of the experiment? Yep, it is 8 because that happened the most times. That's the most frequent. Ariel, I know you're not playing with your phone right now, right? Hell no. I get it, it's your birthday, but guess what? I will snatch that. Okay, I will wig right here. I'll just pull my weed. All right, you ready? Ariel, right here. What is the least frequent?
2.
Right there. Super easy, right? All right, good. All right, so please make sure you like, share, subscribe, hit that notification button, and follow me on my channel.